If you've ever worked on a Java project, you know the pain, right? Manually hunting down library files, dealing with inconsistent project setups, trying to figure out some custom build scripts that only one person on the team actually understands. It can feel like absolute chaos. But what if there was a way to bring some serious order to all that madness? Well, that's exactly what Maven was built for. So let's break it all down.
And this slide, this really gets to the heart of the whole problem versus solution thing. On one side, you have what developers lovingly call class path hell. That tangled mess where your application just can't find the right libraries to even run. But on the other side, you've got the order that Maven brings. Automatic dependencies, a standard layout for every project, and a clear, predictable build process. It's not just a small improvement, it's a total game changer for how you work.
So, what is Maven, really? The official definition calls it a project management and build automation tool. Now, the build part is important for sure, but I really want you to focus on that first part, project management. This is so key. Maven isn't just about compiling code, it's a whole philosophy for how projects should be structured and managed, right from the very beginning. To make that a little clearer, we can break Maven's identity down into three main roles. First, yes, it's a build tool. It compiles your code and packages it all up. Second, it's a dependency manager, and this is arguably its most famous and powerful feature. And maybe most importantly, it acts as a project manager, enforcing a standard structure on every single project it touches. I actually like to think of these roles as Maven's three superpowers. These are the core principles that let it take a totally chaotic development process and turn it into something simple, repeatable, and standardized for everyone on the team. Let's dig into each one. First up is the standardized blueprint. See, at its core, Maven runs on this really powerful idea called convention over configuration. What that means is instead of you having to configure every little detail about where your files go, Maven just gives you a standard directory structure. Your source code, it goes in src/main/java. Your tests, they go in src/test/java. And the final output, that ends up in a target folder. Suddenly, every Maven project on the planet looks familiar, which is a huge deal when you're working on a team. Okay, superpower number 2, the universal librarian. Remember the old days hunting for jar files online, hoping you got the right version? Maven just completely gets rid of that nightmare. You just declare what libraries your project needs, and Maven acts like a super efficient librarian. It goes to a massive central repository, finds the exact versions you asked for, and downloads them for you automatically. And just like that, the headache of managing dependencies is gone. And the third superpower is what I call the extensible toolkit. Now, Maven has a standard built-in process for building software. We call that the build lifecycle, but its real secret weapon is this massive ecosystem of plugins. I mean, you need to analyze your code for bugs? Yep, there's a plugin for that. Need to deploy your application to a server? You guessed it, there's a plugin for that too. It makes Maven incredibly versatile. So let's take a closer look at that build lifecycle. The best way to think about it is like a set of dominoes. You can't get to the last one without tipping over all the ones that come before it. For example, if you tell Maven to run the install phase, it automatically triggers validate, then compile, then test, and then package first, all in that exact order. This whole process ensures a consistent and totally reliable build every single time. Okay, so how does Maven know what to do, right? How does it know which dependencies you need or what plugins to run? Well, it all comes from one central file. The absolute brains of the operation, the pom.xml. Now, POM stands for Project Object Model, and right at its heart are what we call the GAV coordinates. That stands for Group ID, which is usually your company's domain, the Artifact ID, which is just your project's name, and of course, the version. Together, these three things form a completely unique address for your project in the entire Maven universe. And beyond those coordinates, the pom.xml is where you define literally everything else about your project. You declare all your libraries inside the dependencies tag. You customize your build process with different tools using the plugins tag. Pretty much anything and everything that defines your project structure and build process lives right here. It is the single source of truth. All right, so we get the theory. But where do you actually interact with Maven day to day? Because it's not just some tool you run from a black and white terminal screen. Nope, it's actually deeply woven into the entire modern developer workflow. The reality is, you're going to be interacting with Maven all over the place.
Your IDE, whether that's IntelliJ or Eclipse, uses it under the hood to manage your project seamlessly. It's the engine that powers automated CI/CD pipelines like Jenkins that build and deploy your code. And yeah, of course, you can always drop down to the command line for that really precise control.
To really understand how Maven fits in with automation servers like Jenkins, I love this butler analogy. Think of Jenkins as the butler. It doesn't actually do the work itself. It's more of an orchestrator. So when new code gets checked in, Jenkins just calls on the expert, Maven, and says, hey, go build and test this. Jenkins manages the overall workflow, but it's Maven that's doing all the heavy lifting. And that really brings us right back to the beginning. Maven isn't just about some kind of technical elegance, it's about efficiency and collaboration. By standardizing the chaos and automating all that repetitive work, it frees up developers to focus on what they're actually supposed to be doing, writing great code. So the question I want to leave you with is this: how much time and frustration could this level of automation save you and your team?